welcome to the session on practical challenges in the application of DMDU approaches. Today we have a very diverse set of presentations, and I'm excited to really present all of our speakers this afternoon. If you live in the closer to where Mary is, she's in Australia, right, Mary?
Oh, I'm in Denmark.
Denmark. Oh, I don't know why I had this idea that you were in Australia, but so in any case, it's really different times for all of us, and I'm excited to present our first speaker, Mary Wise. And before she starts her presentation, I would just like to remind everybody that you can put your question in the chat. Mary will answer your question, whether if it's relevant to clarify some of the content in her slides. She might take the question right at the moment that you ask it, or we might wait at the end of her presentation. If there are not that many questions for Mary right at when she finishes her presentation, we will continue with Joseph's presentation. But if you had any question for Mary, you can also ask your question by the end of the session. So there are plenty of opportunities that you can interact with the speakers. It can be during their presentation, at the end of their presentation, or at the very end of the session. So again, I welcome everyone, and with that, I think I would like to give the floor to Mary Wise. Please, Mary, you can start your presentation. Thank you.
Hey, thank you very much, Tanya. And it's greetings, everyone. My name is Mary Wise, and I'm the professor of marine science at the World Maritime University, which is the UN university in Malmö, Sweden. And today I'm going to talk to you about a strange place in the ocean, and it's called the mesopelagic zone. So how many of you have ever heard of the mesopelagic zone? Well, you give a little thumbs up or whatever. So that the mesopelagic zone is also called the ocean's twilight zone, and it covers the world's oceans wherever you find a depth between 200 and 1,000 meters below the surface. And we call it the twilight zone because it's a place that's just light enough where you're barely able to see, but it's still too dark for photosynthesis. And so about 60% of the world's ocean has a mesopelagic zone. But it's also one of the most poorly understood ecosystems on our planet. And it's full of a lot of weird things. And so you're going to meet a few of these weird things during this presentation. This animal here, it's a barbelled dragonfish, and they call it the Cinderella of the mesopelagic zone. This is a presentation. Will have a lot of questions. I'm really curious about applying DMDU methods to this ocean system because it is loaded with uncertainties, and it's also a very important system that requires a lot of important decision making for its governance and management. Okay, so now I told you that the ocean twilight zone is full of a lot of weird stuff, and here we go. These are some pictures of some of its residents. The ocean twilight zone is really poorly understood because it's really hard to study. It's less accessible than the shallower waters that we're more familiar with, and it covers such a really big area, and it also changes a lot in space and time. The animals are also really super good at avoiding being detected. So the marine observational technologies that scientists use to study the ocean twilight zone or the mesopelagic zone with nets and cameras and underwater vehicles, the animals are usually pretty good at evading those things. And then also the animals are many of them are gelatinous. They're really, really delicate because they are accustomed to living under pressure. When they're brought up to the surface, very often they turn very, very mushy and gooey, and they're difficult to identify. They're hard to study. But we have learned a lot recently because of due to advances in acoustic technology, genetics, and other forms of marine observation technology. Okay, but Even though they look really scary, these are the giants of the mesopelagic zone. Most of the animals are really, really small. And a lot of them also have a lot of light bioluminescent appendages and organs scattered throughout their bodies. This helps them with camouflage, and it also helps them to attract prey or also to find each other sometimes. So there's also a lot of biomass in the ocean's twilight zone. And this is one of the things that makes it a really important ecosystem for stabilizing our climate and also for providing food, resources for the food web, the marine food web. There's anywhere from around 1 to 10 billion metric tons of biomass. Now, what does that mean? There's also a lot of uncertainty in that estimate, but it's, what I can say is even for the low end, that is more than all capture fisheries combined. So even if we were around 1 billion metric tons, it's still more than all capture fisheries combined. And it's also the most biologically productive community that we know about. There are also a lot of apex predators that feed on the mesopelagic zone. So even though a lot of these mesopelagic animals are maybe unfamiliar to us, things like whales and swordfish and sharks and turtles, they do feed on the mesopelagic zone, and also some marine birds. And so there are a lot of animals that people depend on that are feeding on this particular zone. But there's also there's also a lot of fish. There's a lot of fish. So this is one particular, this is the most abundant vertebrate on our planet, and it's found in the mesopelagic zone. It is a bristlemouth, and this is a genus of fish, and you can count them in thousands of trillions. So I think this is it's not a gazillion. What would it be? It's a very large number. It has 18 zeros after it, and so and these are found throughout the world's oceans, but they're also very, very small. So twilight zone's full of biomass, but we don't know how much. We don't know where it is, where it's concentrated. We don't know when we find it. If there are seasonal changes, we don't know precisely who eats it. We're unsure about the impacts that climate change could have on it, and we're also we're not so sure about if it's vulnerable to activities that humans may impose on this zone. One of the most important things about the mesopelagic or the ocean twilight zone is it moves a lot of carbon around, and it sequesters so much carbon for us that some estimates from various climate Earth system models have shown that that our atmospheric carbon levels would be 50% higher than they are now if it weren't for the activity of the biological activity in this zone. Now, how does this work? The largest animal migration on the planet happens within the ocean twilight zone. Not all of the animals that you find there migrate, but many of them do. When it gets dark, many fish, squid, plankton, and other organisms that we find there, they swim hundreds, maybe even thousands of meters up toward the surface where the nutrients are, and that's where they feed. But then before day comes again, they sink, they drop down to the bottom again, they drop down to the depths again so that they can avoid predation from animals up in the euphotic zone where all the light is. And so they do this every day, and when they do this, they're transporting carbon. They process carbon, they transport carbon and bring it down to the depths. So they're really important in the biological carbon pump. But there's a lot of movement, and there's a lot of uncertainties. We don't know how much carbon is being sequestered in which particular places because it's not uniform everywhere. We also don't know if this changes seasonally or which species are involved in which kinds of movements. We're also unsure about how climate change could impact it. We would think that it should, because climate change can affect, temperatures. It can affect water, this way the water stratifies in the oceans. Also the pH, the oxygen levels. This affects how these animals can perform, because that's how it is for marine organisms. So how do we keep this ecological process safe? That's another big uncertainty because this is an important ecosystem service, and we have an international responsibility to keep that ecological process safe for maintaining our climate. There's also a lot of biodiversity there that we don't know about. And so there's estimated to be around 1 million undescribed species. This comes from the work that has been done, and every time that the scientists go out on their cruises and take samples, they find something brand new. And so they can, with this, estimate what else, what they may be missing that's out there. There are a lot of knowledge gaps. We don't know the role that this biodiversity plays in the ecosystem, and we also don't know what its potential value is to society through the technologies and innovation that could be applied. Perhaps we can derive new medicines. Perhaps there's a lot that we can learn from what the ocean twilight zone has. Now, it's the Anthropocene, and so that means that even in the mesopelagic or the ocean twilight zone, there can be threats from human activities. And the most pressing threat that we know of right now is from deep sea mining. So mining for sulfites, manganese, cobalt, these can result in these in toxic plumes that can reach up to the mesopelagic zone, and this can disturb the ecosystems. It can choke the organisms that are in there, and can introduce toxins, and we're still trying to figure out how they interact or could potentially have an impact on the mesopelagic zone. Currently, EIAs, environmental impact assessments that are carried out at sea, are not required to consider the mesopelagic zone. So we're really interested to find out where the areas for future mining may be carried out, and what the implications of potential treaties that are currently being negotiated, like the Biodiversity Beyond National Jurisdiction treaty that's looking at our international waters and how to govern them and limits activities like and would regulate activities such as mining out in the high seas. So there are other concerns and other interests too at stake here. So as we know, food security is a really great concern for the growing human population. And there's already awareness that land-based agriculture is going to have a hard time getting the job done. So attention has turned to aquaculture, and the EU Commission has recently, within the past couple of years, proposed a call to ask the question, can the ocean's twilight zone biomass sustainably feed the world via fish meal to feed to aquaculture? And this raises many, many different questions. So aquaculture, it's the world's fastest growing food sector. It's, but it requires protein to feed fish in aquaculture. And and a lot of this currently comes from fish meal. So the question is, can fish that are really plentiful in the mesopelagic or the ocean twilight zone, things like lanternfishes, can they be developed or harvested to produce fish meal? And but there are a lot of questions that this raises. How would we catch it? What kind of gear would we require? We currently don't have gear that's optimized for catching such fish. How would we transport it and maintain its quality? Because this is far, far, far off from any coastal area, and so we have to consider how to transport it and keep the fish fresh. How would we make it cost effective? Would it be safe for the human food chain? Would it bioaccumulate toxins if we try to feed it to things that we later eat? How would we weigh, and this is the biggie, how would we weigh today's benefits of harvesting such a resource against tomorrow's costs? Right? So this leads us to the Horizon 2020 project that I'm involved in right now, and this is the MESO project. And this is for to examine ecologically and economically sustainable mesopelagic fisheries to assess, is this really a good idea? Okay, and so the aim is to get biophysical and socioeconomic understanding of the mesopelagic zone through scientific investigations using acoustics, genetics, scientific cruises, and then also looking at things like stakeholder analyses and carrying out analyses and models of the socio-ecological system in order to make recommendations for policy and management and potentially governing this resource and keeping it safe. We aim to identify trajectories for policy and governance and management, and we're very interested in model-based policy analysis using DMDU methods. And so this whole project is coordinated by the Institute of Marine Research at the University of Bergen in Norway. Now, this is my last slide, and this is how we're thinking about approaching this now. And so my group is responsible for the governance work package in the MISO project. And we aim to develop recommendations that are informed by a policy analysis that's supported by socio-ecological modeling. So this is a schematic of how we are planning to approach it. And it's definitely a work in progress. And part of the reason why we're in this, this meeting today is to kind of harvest ideas and discussion for how we can approach it. So currently data are being collected to support the biophysical and socioeconomic models by our fellow scientists in the other work packages. So MISO has scientists out at sea, they're collecting acoustic and genetic data, and economists who are tracking fish meal prices in trade, evaluating the cost of fishing with new gear designed for with mesopelagic fisheries potentially in mind, and then also looking at the cost of transport and so on. Meanwhile, our team is at World Maritime University. We're carrying out our desk-based policy analyses to examine carbon, fisheries, biodiversity policies, and the mandates in the North Atlantic. And then we're going to work in a cross-disciplinary fashion. We're about to start interviewing policymakers and stakeholders and considering national, regional, industry decision makers. And then we're going to proceed with our DMDU modeling methods and we're thinking along the lines of, RDM or dynamic adaptive models. As we gain more information, we think it'd be interesting to update these and see what these flexible methods should be able to offer us. And so the final goal is of our governance work packages to identify robust policy options that consider the uncertainties in the socio-ecological system and also in the decision-making process. And they'll be based on available data and the knowledge that we have in the system. So with that, the ocean twilight zone, it provides lots of ecosystem services. Many uncertainties need to be addressed before we consider any kind of human activities in this zone that's very important for a healthy climate system, and a lot is at stake here. And so we think this is our chance to put the cross-disciplinary social, ecological, scientific evidence in front of any kind of potential exploitation. So thank you.
Thank you very much, Mary. That was really, really interesting talk. And I think the problem that you're looking to, it's really fit into this session so well, because there are so many challenges of how to apply the DMDU approaches to your problem. I think there's one question from the audience in the chat. Ned Gardiner has a question. He also has his hand raised. Oh, I can unmute yourself, Ned, and you can also pose your question if you would like to directly to Mary.
I didn't mean to have my hand raised. That was at the very beginning of the talk when she was saying, indicate if you've heard about.
Oh, I see, I see.
No, that was my mistake. But since I've got the mic, I was interested to hear if you've got successes or failures you'd like to share about communicating the downside risk of, which are substantial, of overharvesting in the ocean, given the effect of the changing chemistry of the ocean and everything else that the ocean is receiving from global change.
That is a very, very good question. And so, I mean, this project just started a year ago. And so, and as I said, this is, you know, the thing that's really important to us is that we put the science first before our recommendations, before anything. And part of one of the work packages that we have is also to assess public opinion and to also investigate the best way to communicate about this too, because it is a very, very delicate discussion with the public as well, and we want to make sure that that the science is communicated very, very well, and we're being very, very careful about, you know, how we communicate it, because it is important to get the messaging right on it. But it's something that, I mean, within the next, I would say, year and a half to 2 years, we hope that we'll have something out from that. But that's Rolf Groneveld's research team from Wageningen in the Netherlands is looking into that, and I'm glad he is. So, yeah.
There's another question from the audience. Though Samuelson asked, how do you track those effects before you know what eats what?
How do you track, sorry?
How would you track the effects of harvesting, I guess, these underwater, these sea creatures, fishes, before you know what eats what? I guess if you don't know that well all the chain of what's the chain there.
Yeah, so the other scientific work packages, and I apologize, I have a very noisy dishwasher that's running in the background. I should have turned it off, but that's these days what we have. The other scientific work packages, what they're doing is they're doing food web analyses. They are looking at the predators and what they've been eating. They are using genetic analyses also stable isotope analyses and other tools to try and understand the relationships of the ecosystem. They're also doing, you know, some experimental fishing to see, to try and through sampling to find out what is down there, and try to look at the structure of the populations, try to look at the demographics of what's there. But because there is so little that we know, it's very, very hard. So it's going to take more information, I think, than what we can get from this particular project before we can you know, say it's safe to go here. I think we'll probably end up more with baseline data, but it's going to take many, many years to understand the system, and so it is going to take a long time before we get there. But it is those are the things that we're trying to understand is how the system works. And then also there are the cruises that they've done so far. What they found is that the system is even more dynamic and difficult to understand than they initially thought, because when they go out, they think that, oh well, here we expect to find only 2 species dominating, and then they may find more, and so it changes in time and space. And so the investigations.
I guess then one of the biggest challenges will be to really have a comprehensive set of policy options that take into account what you find, right, and what can be best for those scenarios that you find, or information that you start gathering from as the project kind of runs. Right?
Yeah.
Well, thank you very much, Mary. I think in the interest of time, we will keep one of the questions that was also for your presentation for the end of the session. And we will now, we will now have Joseph Guillaume present his talk next.
Okay, hi everyone. I'm Joseph Guillaume. I'm a research fellow in the Institute for Water Futures at Australian National University in Canberra. And so I'll be talking about this idea of evolving ways of dealing with uncertainty that actually suit the particular organization and context. And so the starting point is this idea that there's actually a big gap between what decision frameworks tell us we should be doing and how decision making is actually done in practice. And part of that is deliberate, that, we have predictive and prescriptive tools that tell us how decisions should be made. And we say, well, we should be able to do better than what actual practice is. Decision aiding tools, like in DMDU, have tried to bridge the gap of recognizing that the final decision has a lot more things going into it that the decision framework might not have been able to capture. And so what I'll be talking about today is kind of this third element of organizational change, of if we want our decision frameworks to become actual decision making in some form, what is actually required of that. And Caroline Rosello's talk yesterday about adapting integrated models to adapt was in this direction too. So I'll go through 3 points and some examples. The first one is the idea that the gap we're facing is that uncertainty is often addressed through heuristics, shaping of the decision context, so things that are outside of the decision framework itself. And we've got to make sure that the decision framework is able to work well with those. So what we need is capacity to understand, well, what are those things? How is uncertainty actually being managed at the moment in absence of this innovation of introducing new ideas about from decision frameworks? So one approach that we've been trialing, so this is work led by Fatima Zare, is looking at process tracing. So here on the left, we've got the simple process of a two-step process that ends in a dead end, that things didn't turn out the way we want, and so we have to redirect the project in order to do the step 2 prime. And so what she was looking at what communication might have led to a different decision and outcome. So we're not just saying, what different decision could we have made, but in a team context, how could we actually have changed the way that decision was made, in what communication would have actually led straight to decision 2 prime. And so on the right here, we've got an example of the actual case study in the paper. And so the idea is to lay out all of the steps that were actually taken, or rather I should say a conceptualization of the steps that were taken in order to identify where are the spots that we could have intervened in order to change the outcome. This is particularly relevant, obviously, from an uncertainty point of view, of saying, oh, we should have actually addressed uncertainty in a different way earlier on. Where is the point at which we could have changed the course of that project? So another approach that we've been experimenting with is argument mapping. So here's a simple example of an argument map that shows the role of uncertainty. So we're trying to choose between route A and route B. We know route A is slower than route B, but we also know that it's on road and therefore less likely to have obstacles and therefore more certain. And therefore, because of how we deal with that uncertainty, we would choose route A. So this is work by Leila Noble. What she did to apply these concepts is a document analysis that built up what the argument map looks like, interviews to try to complement what was or understand why those decisions were made on how to deal with uncertainty. And as you can imagine, the actual argument map she ended up with, so this is a case of in water policy in Australia, the argument map's a fair bit more complicated, and so there's a certain activity in identifying what are the subunits within it that are worthy of further exploration. And the key idea that came out of that is about the legitimacy of the way of addressing uncertainty that combines adaptive management, best available science, and trade-offs. And how can we make sure that the general public's aware of the magnitude of uncertainty that's actually being faced and the implications of choosing this particular way of addressing uncertainty. So that's by no means the only ways of looking at how uncertainty is currently being addressed, but it just gives you a taste for the kind of techniques we're experimenting with. The second gap I'm talking about is that formal design of decision-making strategies is time consuming. And so sure, we could make sure that more resources are devoted to adoption of decision frameworks, but making that decision itself is time consuming often of getting people on board. And so then necessarily it means that we require shortcuts through bricolage of available techniques. So what we're experimenting with there is really embracing this idea that bricolage is a given. How can we make sure that it's well informed and useful? So how can we break down our key concepts and recombine them in ways that are effective? So an example of this was led by Baihua Fu, a paper published this year. And so what we're seeing here is a process that she followed for a DMDU exploratory modeling process that has pulled together multiple steps and chosen different techniques to address those steps. So my colleague Fatima Zare has also explored this a little bit more formally in a conference paper through the idea of customized model guidelines. So we already know there's lots of efforts to try to describe the standard processes by which we follow. So in this case, we've got the problem that in modeling, well, we already have multiple different modeling guidelines. So here, one on 10 iterative steps of development and evaluation of models, and another one on the steps of modeling with stakeholders. So the first idea there is simply to merge the different processes for a particular context. So we can identify, well, what is the level of granularity with which we want to describe the process we want to actually follow? What is the order in which these things will come? So on the right here, we've got a combination of these steps where in some cases, multiple steps have been merged to get the granularity we want. And in some cases, some of the steps were present in only one of the guidelines and not in one of the other. So being able to do that kind of process isn't enough, though. That's still too broad to be able to have a common understanding of, well, what does each of these steps actually involve? So what we experimented with there is the idea of an ID card for each step. Sorry. And the first priority is to think about, well, what do we want to know about each of the steps? And so this is a fairly straightforward concept in principle. What we simply do is to merge the statements that have been made about each of these categories within the steps to provide a summary that's applicable to this particular case. So that gives you an idea of what we're trying to think about. Well, how do we bring together information so we can recombine it? The third problem that we're talking about is that whenever we have an innovation that we're bringing in, it needs to be compatible with how organizations and individuals are currently thinking about uncertainty. And if it's not compatible, then we need to make sure that we've got steps of the right size to bring them along on that process. And so what we're focusing on here is actually looking at the ripples through the system needed to achieve this a systemic transformation rather than simply disrupting the status quo with a new decision framework. So the example we're working with is with Queensland Government in Australia working on the Great Barrier Reef, and in particular the production of an annual report card. So here you can see, well, our focus is specifically on water quality modeling. We've got a variety of data sources and a variety of data coming from other modeling components, all coming together, involving multiple agencies within government. This is an overview of the advisory committee, and so the colours are showing both Queensland level government organisations, advisory committees, and joint federal government and state government committees all coming together. So it's a fairly complex organisational space we're talking about. So if we think about a central process here where we've got data feeding into modelling, feeding into the report card, feeding into progress tracking by the government and stakeholders, if we think about, well, what is the role of the uncertainty here? And how does it fit with the model management processes of the organisation? So we can think about what is the function of the model within the organisation. Here we're delivering a particular product, or running the model and updating it each year. can think about what notions about certainty and uncertainty are being deployed. And this is what we've got in blue here. And then thinking about what model management leverage points are being employed to support that uncertainty management. So just to give an example, and so that's what we've got in black outside. Sorry. So just to give an example here, if we think about data, not all data is made equal. In order for it to be credible, we're actually using the notion that it is a ground truth for our modeling. And it's not enough to simply say it's a ground truth. The reason that we consider it a ground truth is because we're following certain data collection standards that provide us a certain level of replicability. So to take another example, an issue that came up in the history of this this process is that the report card didn't explicitly address uncertainty. And that's partly because it is a very difficult problem in this kind of complex situation. And so what was actually introduced was a methodological confidence rating that then gave the support of acknowledging that it's not perfect and transparency about what was actually available. And that in turn, the confidence in that confidence rating relies on the fact that there was sign-off from a coordination and advisory group. So what we're focusing on here is kind of a concept of what activities need to happen to support notions about certainty and uncertainty. Another way to think about it isn't just in terms of who is actually involved. So if we think about the nesting of different processes, we've got this central catchment loads modeling process. It falls within something called the paddock to reef program more generally, which is described by a design document. There's oversight from the Office of Great Barrier Reef, and it's feeding into a piece of legislation called the Water Quality Improvement Plan. But on top of that, we've got coordination and advisory groups. We've got, as part of the production of the report card, interactive tool development, review by an independent science panel, as well as other reviews. And it's supporting this. We also have the Queensland Water Modelling Network that includes universities and other consultants and so on, and independent program reviews by tender, as well as broader advisory panels. So when we think about this simple task of adopting a new modeling method, whether it's quantifying uncertainty in water quality or it's adopting DMDU methods, we're going to need to ripple through this system and look at what new data preparation and collection is required, what new messaging will be required, how is that going to be integrated into current views. We have to anticipate the reaction of those advisory groups, seek the necessary feedbacks and approvals. It needs to fit with my ministerial priorities and department budgets, both in order to allow it to happen and to make sure that there's not a negative feedback within there. It's going to have implications for new research agenda and method development of the broader community. And we've got to think about, well, how does this then fit into the next phase of this project? So that gives you a feeling for the kind of ripples that I'm talking about there. And I'll just leave you with these, the three points here. Firstly, that in order to evolve uncertainty management strategies that suit you, we want to make explicit and understand the status quo of how uncertainty is managed now, so that we actually know what is it that we're interfering or intervening in trying to change the way uncertainty is being managed. We want to build capacity for bricolage in a way that's safe and useful, not just ready solutions. And we want to be able to follow the ripples and aim for system transformation, which does mean that in many of these cases, we're talking about long-term change that we're aiming for. Thank you.
Thank you very much, Joseph. That was a very interesting talk that you gave us. There are actually a couple of questions from the audience in the chat. I would like to apologize in advance to everyone if I'm pronouncing your name incorrectly. I'm so sorry. I'll try my best to say your name, or if you like to unmute yourself and directly ask your question to Joseph, you're also welcome to. But I see one question from Liz Coulter. So the question is, how do you account for policy that does not reflect evidence such as yours?
But having lived in Australia, I understand that you could come up with a lot of report cards, but that's not necessarily reflected in policy. How do you account for that, and how do you keep working?
I think the starting point there is to accept that that's what happens. The work I mentioned by Leela Noble actually focused on that issue of it was commendable in the sense that they've actually quantified the uncertainty in the water needed for the environment, but the fact that they did that allowed the space for a political decision, which is turning out to probably have been a little too risky and not achieving the desired outcomes for the environment. And so if we start from that premise that we know that that's what's going to happen, then it's about legitimacy of the process for determining what is best available science in this case, what evidence should be supported, how does the public get to democratically influence whether or not the right information is being used. So it's kind of an unsatisfactory answer from a scientific point of view that we feel that like the evidence we believe should be included might not be included, but it really does turn into a governance problem of how do we decide which evidence should be used for a particular situation, what framing should be used for a problem.
So do you find that the focus on uncertainty is actually detrimental to communication to policy?
The focus on producing uncertainty bounds is potentially detrimental and should be used with caution. What we're actually emphasizing though is that greater attention to uncertainty management is really needed. That at the moment, we don't even really have a concept of how is uncertainty managed in this decision. It's not something we think about. And so in order to have a legitimate decision about how uncertainty is managed, there needs to be capacity to have a dialogue about it. And so we need to be able to talk about how is uncertainty managed in this case.
Thank you.
Thank you, Joseph. Do you think, just a follow-up question, there are actually a couple of questions here, but follow-up questions to this. Do you think is it the job of the analyst to kind of give this information to the stakeholder? So whatever uncertainty bounds you find, is it your job to tell directly to the stakeholder even if they didn't really want to hear about all this uncertainty? Or is it maybe potentially your job also to find out how they would potentially manage the uncertainty that you found?
It's definitely the job of the analyst to think about how uncertainty should be communicated to the people they're interacting with. In some cases, the actual organizational framework says what are the deliverables and so on. I think in general, for transparency, it is useful for an analyst to have a picture of how uncertain their work is. It's then just a question of how that's communicated. That's the big issue.
Thank you.
So yeah, there's a difference between internal uncertainty quantification versus for external purposes.
Thank you. I think I'll read one more question from the audience and then we're going to start Paola's presentation. There's one really long question from Jim Maltby. I think I might leave that by the end, but if that's okay, I will read the question. It says, is there a role for counterfactuals when there is structural biases to actively avoid uncertainty in policy or proposed actions?
Maybe Pat, could you say what your interpretation of counterfactuals is in this case?
So the questions that aren't allowed to be asked within an institutional construct by a hierarchical power structure and maybe asymmetries of influence. So when you do your mapping, it's very clear that the most critical questions or underlying uncertainties can't be addressed. So in that circumstance, is there a role where the counterfactual or external pressure or some change in sort of the way you're thinking about these tools, where there's sort of an internal forced ignorance towards key considerations.
I think absolutely. I think a key idea here when we're talking about innovation and change is being able to imagine and then make concrete what are the alternatives we're talking about. And so that's part of the idea behind the process tracing and pathway diagram of being able to describe, well, what are the alternative paths that could have been followed. And so that works at several levels. We can talk about the counterfactuals for the actual process, as well as counterfactuals for the outcomes of alternative decisions. And this is also where it's worth thinking about about the system, not just in terms of what the government's doing or the organization making the decision, but also what the other stakeholders are actually thinking about it and what other pathways we have for influencing those outcomes. And so that fits in with that legitimacy problem of saying, well, can we change, put enough pressure for change from the outside through the use of counterfactuals?
Thank you, Joseph. I hope that answered your question, Patrick. And in the interest of time, we're gonna start with Paola's presentation, and then at the end, please, for those questions that we didn't answer right now, please stay in the session. We will definitely answer your questions by the end. Thank you, Jim and Adolfo for waiting for that. Thank you, Joseph, and the floor is yours, Paola.
Thank you. Good afternoon, everybody. My name is Paola Gomez Priego, and I'm a PhD candidate in the Sustainability Sciences program at the National Autonomous University of Mexico, UNAM. And I present in collaboration with the researcher Luis Bojorquez. So what is environmental impact assessment? EIA or EIA. EIA is the most institutionalized decision planning tool in the world. It is a requirement by funding institutions for development projects, and it represents, in most cases, the last opportunity for public participation in decision making. EIA aims to predict the negative environmental impacts of a project and to propose effective prevention, mitigation, and compensation measures. As some of you may guess, in practice, EIA has tremendous limitations and is often immersed in controversy, uncertainty, and mistrust. Yet possibly its main challenge resides in its reliance on expert judgment. So for EIA, one of the most important aspects is the determination of impact significance. That is, the degree to which a project justifies either its rejection or authorization by environmental authorities. The figure below shows how impact significance is often represented as a hard threshold of what is acceptable in a continuum of disturbances or impacts. One could argue that the main sources of deep uncertainty in EIA are the metric estimations that conform impact significance, the thresholds of what constitutes acceptable versus unacceptable, and the effectiveness and efficiency of the post-authorization measures. So let us take the taxonomy of robustness frameworks proposed by Herman to place conventional EIA in a DMDU context, where basically the discovery of alternatives, the key factors and scenarios ranges from very limited to almost non-existent, and there are no robustness measures or controls. We therefore propose a shift towards robust environmental impact assessment in which the alternatives and states of the world are discovered and robustness measures and controls are integrated. We want to focus particularly in this talk on who gets to decide what states of the world are considered, and how uncertainties other than epistemic, that is, of what we know, are incorporated into the decision-making process. So what are these other uncertainties? There is the ontological, which describes the uncertainty about the actor beliefs of what kinds of entities inhabit the world and what kinds of interactions are among those entities. For example, what variables should be considered in a particular assessment. There is a semantic uncertainty, where actors are uncertain about what a proposition means, and arises in discursive interactions among actors. For example, is my definition of impact significance different from yours or the same as yours? And the predicate uncertainty, where linguistic categories lack a definite meaning. For example, what is the difference between very high impact significance or just high impact significance? We want to particularly propose the use of analytical deliberation as a way to improve EIA by providing useful information about the states of the world, but within a structured, recursive, and collaborative process of reflection, justification, and persuasion to reach an agreement. This process should aim to facilitate an open examination of the knowledge, beliefs, and uncertainties of actors. This means that these approaches should incorporate opposing narratives, as well as the inherent imprecision and ambiguity of the meaning of impact significance. So, had this approach been tested? What we're proposing is being tested, and the answer is yes. We're still working on it, but it was incorporated in a mega tourism development project in the Pacific coast of Mexico, where conflict arose as the result of two radical opposing narratives, and the authorization of EIA was subject to the resolution of this conflict. So I'm not going to go into details, but impact significance is conventionally measured through indices and indicators. In this illustration with the interaction intensity and vulnerability indices shown on the left. So the study area is divided into land units, as shown on the right, and experts estimated the values of each indicator for every land unit for every type of impact. The types of impacts may be like erosion, habitat loss, landscape quality. The resulting impact significance estimations then are typically combined and classified by experts, usually the ones that are in charge of the EIA, and usually they are contracted by the developer of the project. We, however, did differently. We aimed for a collaborative and yet rigorous combination of indices through a fuzzy pattern classification algorithm that allowed for the exploration of opposing narratives. These narratives were methodologically incorporated as decision tables, what I'm showing at the top of the figure. And in this case, you can see on the left the developer, the neutral, and then the conservationist, and different views of integrate the world and to integrate indices showed before. Additionally, a grading of different category cuts were tested through the modification of the progression factor. So to facilitate deliberation, the algorithm was integrated into a geovisualization web-based platform called Significance that allowed for the examination of different spatial representations. So I'm going to show you how this looks. So this is the actual web platform, and this is the project that I was showing you, and this representation shows the customary way to integrate results for developers, which is by using equidistant category cuts, as shown in this section, where everything is green and pretty, and the narrative used to integrate this was the developer. I'll show you the other extreme. I'm going to choose the conservationist narrative, and I'm going to go to the extreme of category cuts with the changing the progression factor to 2. And now, this representation initially was preferred by opponents of the project, but it was ultimately discarded because it did not distinguish between important attributes of the landscape. Almost everything was estimated as very high. There was no way to show a gradient. So by changing two parameters, the progression factor, in this case, interactively with different actors, opposing actors, we aimed for the translation and communications of results in a collaborative process where it was required for participants to justify with arguments why a spatial representation, should be discarded. So it was not to select which one is my favorite, but rather to say with arguments and knowledge and beliefs, why should I discard something? And then we could actually understand the other participants' viewpoints and opposing actors acquire new knowledge, including the areas where the spatial representations did not change regardless of which narrative or progression factor selected. And it made it easier to narrate a discussion on the most relevant issues and concerns. Very importantly, participants felt that their knowledge and viewpoints were considered. And this was also because a great result was incorporated into the assessment. So this is just a very small synthesis of different spatial representations. And we believe that our approach aided in the discovery of states of the world in a collaborative way. Ultimately, an agreement of the best representation for this project, and is what you see on the left. And as a conclusion, we believe that although it's a work in progress, the contribution of our approach was to incorporate states of the world according to different narratives, to shift from adversarial to collaborative, to reveal underlying values manifested as uncertainties, to contrast opposing narratives versus knowledge, to achieve a collective meaning of impact significance, and to improve credibility and legitimacy of EIA. So what should the research agenda for EIA in the context of DMDU? We believe that a lot needs to be done. We don't know for which stages of EIA is DMDU most useful. Should be for the design of redesign of projects versus the design of mitigation measures, or just testing the robustness of metrics, or optimization of mitigation measures. And we are very aware that there are a lot of challenges from incorporating DMDU and EIA. There's a lot of capacity building needed. What should the role of experts be? What is the role of translation of communication when you integrate a lot of difficult models and that you have to do in a very short time and with very limited budgets? And what should the role of EIA be in all these new adaptation policymaking procedures that are trying to be implemented? And thank you very much.
Thank you, Paola. That was really an amazing presentation. There are a couple questions from the audience. I will read Ned's question. So, well, he would like to know if this interface is available for us to actually play with it. I don't know if you could share with us the website in the chat. And another thing that he asked is, do participants understand the weighting scheme and parameters used in the vulnerability assessment? And he asks because his experience, it is very difficult to determining those rule sets.
Yes, the first question, is it available? It will be. very soon. If it's just for showing purposes, of course, we can give you access. This is going to be part of a portfolio of assessment tools that we are, I mean my institution that I work for, Lances, that is going to be actually using for different planning projects. So you can write me. Just go back to the first slide where my email is, and we can arrange for you to play with it if you want to. On the other hand, it was asking about the vulnerability indices. Some of those indicators are difficult to communicate. However, what we found in this project in particular is that stakeholders were very clear about what they thought was wrong about these kinds of projects and what they wanted to see and understand once you show them an integration. Then you can go and discuss why particular value does not correspond with what they understand of, and then you can trace back. Then you have to say, okay, you're fitting this value with this vulnerability index value, and then trace back why it was done in a certain way. So by going backwards within, it's easier to explain something. Yet we are aware that we need to improve the way these metrics are done. I mean, one of the major critics of EIA is that it's very technical and lay people are not able to understand this. So we're trying to make simplifications that sometimes are considered black boxes, but trying to go back if something doesn't agree with how people perceive or what knowledge people have of the world.
That's really a great question. Great question and great answer. I think that that question. There's a second question from Geoff Darth. Says, do you see this as a complement? Do you see this as a complementary with systematic conservation planning, which takes a deliberative approach, including trade-offs?
Okay. If it's consistent with conservation planning, well, impact assessment tends to follow, it depends on the part of the world you live in, to certain laws that you need to apply. So a lot of these, the result of the indices are predefined thresholds of what is permitted or not in a certain area. And you need to incorporate that. On the other hand, I think the conservation advocacy groups that were the opposing stakeholders in this project pretty much helped to rebalance how the project was viewed. And actually during the process, I didn't have time to say that, but actually the project was redesigned because of these conservation advocacy groups. So the result was not only part of the showing that what significance was, but also a lot of the redesign of how the project was going to operate had to take place.
Thank you, Paola. I think we might just take 5 more minutes from the session because I would like to bring again back all the speakers. Thank you, Paola. Joseph and Mary, are you still there? I think there were still a couple questions for you in the chat.
Yeah.
Mary, I think there was this last question for you. Would you like me to read it?
Yes.
Says,
Yes, please, yes.
So for your study, do you use existing socioeconomic models for a scenario assessment or develop a custom one?
Well, we're at the very beginning, as I'd mentioned, but I think that what we're probably going to end up doing is go with something custom, but it will be a little bit of a blend depending on the information that our the collaborating work packages in this project end up delivering, because we have been and also I also have to say too that the socio-ecological models have will not be explored to to the depth that of all of the. There were so many questions that I proposed as well, and of course we won't be able to address all of these, so we'll have to focus and we'll have to pick some that are realistic to address in the project timeframe. We're working with, I mean, I think, the easiest way to try to implement something may be through the end-to-end models that that we're looking at, that are looking at different kinds of fisheries exploitation scenarios with different kinds of gear and looking at the economic costs that are associated with using different kinds of gear in different places and different times and different distances from the coast, and so that would probably be the lowest hanging fruit, I think, is to explore those. But then other things too, trying to look at a fish meal trade and so on across scales. I mean, I'd be very fascinated to see how we could explore that, but still we have not begun yet to discuss how we'll explore it. So with our collaborators, thank you for the question.
There are just so many dimensions in the problem that you're looking into that it's really there are different things that you can focus on.
I'm looking forward to help from the DMDU community and get other people interested in the mesopelagic.
For sure, yeah. A lot of people were saying that all your pictures were very beautiful and inspiring. I think that was really interesting for a lot of people in our session.
Well, for those, I have to credit Woods Hole Oceanographic Institute for their Ocean Twilight Zone project and the education materials that they've developed, because they really are inspiring pictures and exciting to see. So yeah.
Thank you, Mary. And just a last question. There was a last question for Joseph from Jim Malky.
Mm-hmm.
It says, when you talk about individuals being comfortable with the thinking, are you trying to improve the skill so that they are more skillful, I guess, or thus more comfortable, or making the tool more amenable, or the user? I guess Jim is also here. Maybe he can clarify a bit about the question.
Do you want me to?
Hi, Jim.
Yeah,
yes, please. I think it's just easier if you.
So Joseph, that was really interesting, and one of the things that I've kind of been interested in is about how decision makers actually make decisions, and how DMDU kind of supports that. So I was kind of, when you're talking about people being more comfortable with the thinking, are you trying to get them to think differently, or are you trying to get the tool to meet their comfort level, if that makes sense? And I was really interested in the argumentation part, because my view is that, and I think that the final talk talks about it a little bit, is that I think that from what I see, the DMDU tools help people in some ways deliberate and debate and get away from being adversarial and kind of seeking more understanding. And as Pat said, actually, you can bring in more counterfactual kind of reasoning to get people to kind of think differently. And is that kind of the space you're in and thinking of with your work?
I suppose this actually comes down to part of the title that I didn't emphasize too much, evolving. I really do see this as kind of an evolution-like situation. And I suppose there's an element of natural selection of what actually survives when you try things. And from that point of view, it is just about ecological fit of, it's not just about changing the skills or changing the framework, it's probably about changing both. And in some cases, you know, it's about waiting long enough that people who are rejecting the thinking move on to other jobs or retire. So it is really at that breadth. I suppose in terms of achieving change, there's also various things to think about there. It's often easy to make a once-off intervention, even as an outsider, that will have impact of some sort on the immediate process. But if you're trying to institutionalize that it becomes a practice that's done for every new decision of this type, then that's a much higher bar. And so in terms of the second part of that question there of organizations that inhibit skill development, it really is about finding the champions. And I think the idea of, you know, the innovation adopters curve is really important, that you've got to know where you are on that curve, whether you're really targeting just the most eager beavers, or whether you're kind of in that mid space or you're trying to scale up, or you're at the last bit where you can really use the internal pressure to force whoever's left to adopt it because everybody else has. So I think it's worth seeing it from that kind of really broad perspective.
No, thank you, Joseph. I think we already took about some time. Sorry, I apologize about that, but I think it was a really good discussion at the end as well. And so I would like to close the session, but first, thank you very much to all our presenters. All your talks were really amazing and insightful. I enjoyed, and I'm sure all the audience as well enjoyed very much your presentations. Thank you all, and I hope you continue enjoying the DMDU meeting tomorrow.